was thrown from a height of 10 feet, reaches maximum height of 17 feet after it's traveled a horizontal distance of 4 feet. We need to write the equation of the parabola that models the situation. Okay. That's a separate handout. So I'm just going to draw a quick sketch. Nothing too elaborate, but something to kind of focus on as we try to do the work. All right, we're going to do it algebraically first, and then we'll check it with the calculator. So its initial height is 10 feet. So I'll just call this 10 feet. But if it's initial, if that's where it's starting, then that would be the y-intercept, so it would have coordinates of 0, 10. Let me bring it in a little bit. Then it goes up in the air, comes back down. I'm assuming it hits the ground. All right. But it's going to reach a maximum height of 17 feet after it's traveled a horizontal distance of 4 feet. So it's saying that it went over 4 units and up 17. So this would be coordinates 4, 17. Since it's the maximum, that makes it the vertex. So what we're comparing here is x and y. So there's no time component here. But instead of saying y, we're going to say f of x. All right. So on Friday, we learned that the y-intercept is the c value of the quadratic function in general form. So if I write the most general form, ax squared plus bx plus c, I can immediately state that the c value has to be 10. Okay, we have that information right away. Now they tell us we have an ordered pair of 417, a coordinate. So 417, that's the same as saying f of 4 is equal to 17. All right, which tells me that I could take my original function, well, modified a little bit, 10 replacing the c, but I can replace each x with a 4 and set the whole thing equal to 17. All right, so f of 4 is going to be equal to a times 4 squared plus b times 4 plus 10. I can only simplify a little bit, just the 4 squared part. So we'll have 16a plus 4b plus 10. That's going to be equal to f of 4. All right, but we also know that f of 4 is equal to 17. So we have an equivalence relation. These two expressions are equal to one another. So I can now say 16a plus 4b plus 10 is equal to 17. All right, can't do much with that because I have a single equation with 2 variables. All right, but I do know that my axis of symmetry is equal to 4. So this 4 here is my axis of symmetry, a of s. We know the axis of symmetry equation, x is equal to negative b over 2a. So instead of saying x is equal to negative b over 2a, I'll say 4 is equal to negative b over 2a. All right. If I cross multiply and solve, I can get the value of b in terms of a. All right, so I put that 4 over a 1, cross multiply, I'm going to get 8a is equal to negative b. But if I divide both sides by negative 1, divide or multiply both sides by negative 1, it doesn't make a difference. Bottom line is b is going to be equal to negative 8. Oh, sorry, negative 8a. It'd be nice if it was just a negative 8. We'd be pretty much done with the problem. But now I can replace the b in the other equation with a negative 8a. All right. So I can say 16a plus 4 times my new b value, which is negative 8a. I could simplify that, and that'll allow me to solve for the value of a. So 16a minus 32a plus 10 is equal to 17. All right, I can combine these terms. I'll move it up a little bit. Combine these terms. And I could also subtract off simultaneously. I could subtract off the 10 from both sides. So on the left, I'm just going to have a 16, negative 16a. On the right, I'm going to have a 7. So to get the value of a, all I would need to do is divide both sides by negative 16. And I would get a is equal to negative 7 over 16. But then I need to figure out the b value. All right, but that should be easy because we know b is equal to negative 8a. So I can replace the a in this equation with a negative 7 over 16. So I'd write this as b equals negative 8 times negative 7 over 16, which would give me b equal to just well, I was going to say a clean 7 over 2. I mean, relatively clean. It's a little bit nicer than negative 7/16, but you know, it's not ideal. All right. Anytime you're dealing with the fractions, it's not going to be, like I said, ideal, but you know, we can live with it. You know, these aren't the worst fractions ever. All right. So again, our function, oops, that took off on me. Our function, normally f of x is equal to ax squared plus bx plus c. We knew that the c was equal to 10. We now know that the a value is negative 7/16. We now know that the b value is 7 over 2. The c value was the 10. So this would be my function. And so you could put that in a calculator and have a look and just make sure that it goes through the correct points. I'll do it in the TI. Just remember, to get a fraction, I mean, unless you want to use the division function, that's fine too. But to get a fraction, it's alpha y equals n over d. So negative 7 over 16. It's a little cleaner that way. X squared plus 7 over 2. You can put it in as 3.5 if you want, but I'll just keep putting it in as a fraction. X, and then plus the 10. And I just need to make sure that it's going to capture the 2 points that they gave me. I don't even have to look at the picture. Just go to the table and make sure 0, 10, and 417 is in the list. So if I go into the table, I'm a little out of whack here, so let me scroll up. So I got 0, 10. I got a lot of fractions, but I also have 417. Those 2 given points needed to be in the list. They are, so we're good. All right. So now what I want to do is go over how to do it, or how to find this equation in the calculator. It's much quicker, but you got to know the process. All right. So again, we need to know 3 points. All right. So we have 2 points, but we also know the axis of symmetry allows us to reflect any point from one side of the parabola to the other. All right. So if I know 0, 10 is 4 units away from the axis of symmetry to the left, there has to be another point that's 4 units away from the axis of symmetry to the right. All right. So the height doesn't change, but the x value does. So we start off with the y-axis. We go to the right 4. We go to the right 4 more. We're really going to the right 8. So 8, 10 would be another point that we can assume. All right. So we're going to do stat edit. And in L1, we're going to put all of our x values, 0, 4, and 8. In our L2, we're going to put all our y values, 10, the corresponding y values, 10, 17, and 10 again. All right. So I'm going to quit out of here so I can do that. I already have the points in there from before, so, you know, kind of cheating a little bit, but if you have some data in there that you don't want, you always go up to the column heading, hit clear, and enter. All right. Go up to the column heading, hit clear, and enter. All right. So I'll just retype it. It's only 3 coordinates anyway. So 10, 17, 10. So you have your values in. So then you do stat calc, option 5. Make sure it has L1, L2 as the references, X list, Y list, and go right on down to calculate. It gives you these values. The R squared tells you the percent fit. I mean, it's more elaborate than that, but for our purposes, that's what it means. So that means that this equation is a perfect fit for the 3 points that we put in. All right, we just need this in fraction form. The 3.5 is easy enough, but that negative 0.4375, quit out of here, negative 0.4375, math, enter, enter. All right, and that'll give you your negative 7/16. We already knew the 10, whether we knew it from the framing of the problem or from the calculator. And like I said, the 3.5, that's easy enough. But, you know, maybe you don't want to take the chance. So convert that over too if you want. All right. But that's the process.